outcomes. The paper categorizes biases into three main types: data bias, algorithmic bias, and human use bias.
Let's start with data bias. What does that entail?
Data bias arises from flaws in the data itself. It could be due to historical circumstances like past discrimination reflected in the data, or it could stem from an unrepresentative sample. For example, an insurance algorithm trained on data predominantly from one region might unfairly penalize residents of other regions.
So the bias is baked into the data from the start.
Exactly. And that bias gets amplified by the algorithm. Then we have algorithmic bias, which is introduced during the design of the algorithm itself. Even with unbiased data, an algorithm can still produce biased outcomes if its objectives or weighting mechanisms are flawed.
Can you give us an example?
Sure. Imagine a loan approval algorithm designed to maximize overall accuracy. It might inadvertently favor certain demographic groups over others, even if those groups have similar creditworthiness.
So even if the algorithm appears accurate overall, it can still perpetuate underlying biases.
Precisely. And finally, we have human use bias, which refers to how humans interpret and apply the algorithm's output. Our own biases can influence how we use AI, potentially leading to discriminatory practices.
That's a crucial point. It's not just about fixing the algorithms, but also about addressing our own biases as users.